In example 4, we have the total cost and total revenue in dollars for the production and sale of ski jackets. So in this case, we don't need to construct the revenue function. That's simply provided for us. In part A, we want to find the marginal revenue and then the value of x where the graph of the revenue function has a horizontal tangent line. So this would mean taking the derivative of 200x minus 0.2x squared to get our marginal revenue function of 200 minus 0.4x, and then to find where our function has a horizontal tangent line, we'll take that derivative function, set it equal to 0, and solve for x. So in this case, it would be at a value of x equals 500. So our revenue function will have a horizontal tangent line at x equals 500. Next, we want to find the profit function and the marginal profit function. So to do this, we want to keep in mind that revenue or profit is revenue minus cost. So if we take 200x minus 0.2x squared and then subtract in parentheses our cost function to make sure we're subtracting that entire function, this gives us a profit function of negative 0.2x squared plus 182 minus 23.405. Then we can again find the derivative of that profit function to get our marginal profit function, which in this case will be 182 minus 0.4x. And then in part C, we're asked to find the values of x where the graph of p of x, so where our profit function, has a horizontal tangent line. So we would again take the derivative function, but in this case the derivative of our profit function, set that equal to 0, and solve for x to get a value of 455. So the last thing we want to do for this example is graph the cost, revenue, and profit functions all in the same coordinate system for x between 0 and 1,000, and then we want to find the production levels that will cause the company to break even. So this means we can plot each of our functions, so 18x plus 23,405, and then separating these with commas, we can include our revenue function and then our profit function. And we want to graph this for 0 less than or equal to x, less than or equal to 1,000. So again, verify that we've got each of those functions typed in correctly. We can see in blue that cost function, the straight line. In red, the taller parabola is our revenue function, and then in the sort of yellowish color is our profit function, that lower parabola. So we can graph each of those, and then we also want to find the production levels that will cause the company to break even. So one method that we can do is to take the revenue and cost function, set those equal to each other and solve. Another method would be to take just the profit function and find where that's equal to 0. So to break even means you don't make any money. So if we take our profit function, set it equal to 0 and solve, this should give us the same results as taking our revenue and cost functions, setting those equal to each other and solving. And in this case, we get two break-even points, one at a production level of 155 and the other at a production level of 755. So we can graph all three of those functions simultaneously, and then we would have two different methods for finding those break-even points.